We all know the basic physics of copper wiring, right?
Hmm.
You run a standard SDI cable, and somewhere around that 300-foot mark, you hit a wall.
Yeah, the signal completely falls off a cliff.
Exactly. And usually that means daisy chaining repeaters or, switching to an IP stream, which brings in latency and compression artifacts that nobody wants.
Right, which is exactly why dedicated fiber extenders are still the absolute gold standard for broadcast. And today, we're looking at a piece of hardware that pushes that cliff out to nearly 19
We
miles.
are. Welcome to today's deep dive. We're unpacking the product specs for the Kramer 613 RNT, sourced from HD-TV Supply. Our mission here is to really understand how this fiber optic tech transforms video transmission range from just feet to actual miles.
It's a fascinating spec sheet because it's a dedicated point-to-point solution designed to push 3G SDI signals without touching the network stack at all. No IP addresses, no buffering.
Just raw throughput. So
Yeah.
let's talk about the actual architecture. We have a transmitter, the 613T, and the receiver, the 613R.
Right. The 613T takes your standard BNC input handling the electrical digital feed, and the magic happens when it converts that into an optical signal out through an ST connector.
And it specifically uses single-mode fiber, which is a critical choice here.
It really is. I mean, unlike multi-mode fiber, which suffers from modal dispersion over long runs, single mode allows this system to maintain signal integrity up to 30 kilometers.
That is 18.6 miles for those of us not thinking in metric.
Yeah, it's a massive range for a single hop.
It is, but my initial concern with that kind of distance is usually signal degradation. I mean, even light has attenuation limits over 19 miles.
Of course. And that is where the internal processing comes into play. Kramer highlights their equalization and their reclocking technology.
Okay, I always get a little skeptical when I see trademark terms, especially reclocking spelled with a K. Is that just marketing speak for a standard repeater?
Well, it's definitely doing more than just simple amplification. Because if you just amplify a signal after 30 kilometers, you would...
You're amplifying the noise.
Exactly, you're amplifying all the noise along with it. Reclocking means the receiver actually recovers the clock data from the incoming stream. It strips away the jitter and regenerates a pristine digital clock before it converts it back to the original digital format.
So it's effectively reconstructing the digital signal from scratch, not just boosting a weak one. That explains how they maintain that 3 gigabit per second maximum data rate.
Right, which gives you resolutions up to WXGA at 60 Hz or standard 1080p without breaking a sweat.
And it supports the full stack of video standards, too. You've got SDI, HD-SDI, 3G HD-SDI.
It even handles DVB ASI for anyone working in broadcast transport streams.
Which makes it a really robust solution for campus-wide distribution or linking separate venues across the city.
Yeah, and you would think a system handling that much data over a laser network would be massive.
Right, like a bulky 2U server. But looking at the form factor, it's part of the Kramer tools family.
They are incredibly compact. You can actually mount 3 of these units side by side in a single 1U rack space.
That is tiny. But wait, packing high-powered lasers into something the size of a deck of cards, does that make installation a nightmare? What about laser safety?
They actually kept it to Laser Class 1 compliance. It fully complies with IEC and FDA standards.
Okay, so you don't need specialized hazardous containment areas or anything?
No, it's perfectly safe under normal operating conditions. It really is headache-free.
So essentially what you're getting is a 19-mile extension that acts like a really long patch cable.
That is the true utility of it. It removes distance from the equation entirely. You get the reliability of a hardline connection, but with the reach of a transmission tower.
It's a great reminder that sometimes the best solution isn't the newest cloud software or IP routing. It's just a dedicated beam of light through glass. So here is a thought to leave you with.
Go for it.
Next time you see a live from the scene broadcast, consider the invisible infrastructure at play. Consider the sheer physics of keeping that high-definition video uncompressed as it traverses a city instantly. It isn't magic. It's clock recovery and coherent light. Thanks for joining us for this deep dive. See you next time.